Hi, sixth graders. We are on our last video for the unit, for Unit 8, and this is surface area of a prism, of a rectangular prism is what we probably want to add on there. All right, so remember a rectangular prism. It's something that looks like this. It means that it has a base of a rectangle. So we could consider this our base, or we could consider this our base, but it means that the bases are rectangles. So the surface area means that we want to find the area of a 3D figure around the figure, or like the area of all of the sides of a 3D figure. So write down surface area of a rectangular prism, and then you're going to write this as the formula. So basically what we're doing is we're adding up all the sides of the area of the rectangular prism. If you look at this, it's a rectangular prism taken apart, so it's basically this unfolded, and you can see that there's a top and a bottom, obviously, a back and a front, and a side and a side. So here's our top, here's our bottom down down there. There's our side, and then obviously our back there, and our front right there. So we're taking the area of all the sides. All right, let's do some examples together. So when we think of surface area, it's basically kind of like wrapping a present. Like we need to know how much wrapping paper we would need to wrap the entire outside of a box. That's basically what surface area is. So we can think about the different sides, and we know, because it's a rectangular prism, we know that this front right here is going to be the same as the back right there. So remember the formula that you just wrote out. Surface area is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. It might be in a different order that you just wrote out, but because it's addition, it doesn't matter the order that you do it. Basically, you're taking the sides and you're kind of pairing them up with each other and multiplying them times 2. So we can see that this front right here, this rectangle, because the height is 13, I know that this is a 9 by 13. And there's 2 of them. So I'm going to do 2 times 9 times 13. Plus, now I can do this, my sides right here. My sides I can see are 7 by 13. So now I'm going to do 2 times 7 times 13. And then I look at my top. Let's get a different color up here. My top, which I can see, this is the length is 9, and the width is going to be 7, because here's my 9, here's my 7. It's hard to point to things when I'm not able to sit and point, so I have to use my pen. So then I have 2 times 9 times 7. Remember, we have to do the 2 because there's 2 of them in the rectangular prism. And then we can add them together. So I'm going to use my calculator to do this step by step. So 2 times 9 times 13 is 234. 2 times 7 times 13 is 182. And then 2 times 9 times 7 is 126. Now I'm going to add all these up together. 234 plus 182 plus 126 equals 542. It's a 3D figure, but we're finding the area, so it's going to be inches squared. All right, if you feel comfortable and want to try this one, oops, not meaning to like turn it, If you want to find this one on your own, why don't you pause me and try to find this one on your own? Or feel free to watch and write it down for another example in your notebook. So we have my front and my back are rectangles of 10 by 6. So 10 by 6, and we have 2 of those. So 2 times 10 times 6, plus we have our side, which is a 3 by 6. So I'm going to kind of draw that like that. 3 by 6. So 2 times 3 times 6. And then we have our top and our bottom, which is a 10 by 3. So then it's going to be 2 times 10 times 3. And then we can add them together. So 2 times 10 is 20 times 6. I know 6 times 2 is 12. Add the 0. So 120. Plus 2 times 3 is 6. Times 6 is 36. Plus 2 times 10 is 20. Times 3 would be 60. So then let's put this into our calculator, which I can probably do in my head, but I tend to make simple little mistakes on these videos. So let's make sure that we're right. And I get 216 meters squared. All right, and last one. We have the largest corrugated cardboard box ever constructed, measured about 23 feet long, 9 feet high, and 8 feet wide. Would 950 square feet of paper be enough to cover the box? So remember, our surface area is 2 times the length times the width, plus 2 times the width times the height, plus 2 times the length times the height. So notice I have length in here twice, width in here twice, height in here twice. So as long as they're all being paired up, multiplied by each other, times 2, then we're good. We got all the sides. So let's fill this in with what we know. So 2 times, my length is 23, and I'm going to use parentheses, which means multiplication, times 8, which is my width, plus 2 times 8 times 9, plus 2 times 23 times 9. And then I check, and when I know that I have the right matchups, because again, I can see 23 in here twice, 8 in here twice, and 9 in here twice. If I have a number more than twice, unless of course if they're the same, like if the length and the width were the same or something, but if I have a number in here twice, then I have them matched up wrong. Or if I don't have a number at all, then we've forgotten about one or two of the sides. So then let's calculate this. And I think it's best if you just do your multiplication out step by step. So let's do this one separate, that one separate. So 2 times 23 times 8 is 368. And then I have 2 times 8 times 9, which is 144, plus 2 times 23 times 9, which is 414. Then let's add those together. 414 plus 144 plus 368 equals 926 feet squared. Now it's asking us, would 950 square feet of paper be enough to cover the box? So our answer would be yes, obviously, because 950 is greater than 926. So that would be my justification. I have more paper than I do the sides of the box, so I would have a little bit left over. If 1 foot was added to each dimension of the largest cardboard box, would 950 square feet still be enough? So I want you to add a foot to all of the dimensions and find the surface area and then tell me if there would be enough paper. So do that, or pause me, do that, and then come back and unpause and check. So now our dimensions are going to be 24 by 10 by 9. And these X's just kind of stand for the dimensions of the box. So now we have 2 times 24 times 9 plus 2 times 24 times 10 plus 2 times 10 times 9. And I always take a second to double check that I have 2 9s, 2 10s, 2 24s. All right, 2 times 24 times 9 is 432. 2 times 24 times 10 is 480. And then 2 times 10 times 9 is 180. Let's add those together. So 432 plus 480 plus 180 equals 1,092 feet. Oops, I don't know what I just did. 1,092 feet squared, which now, no, I do not have enough because 950 is less than 1,092. All right, that is all that I have for you. Have your notes in class, and we'll see you tomorrow.